All right, so today what we want to look at is we want to continue looking at data and doing different things with statistics and data. But we're going to look at some way to represent that data. We've looked at, scatter plots or charts. We've looked at histograms. You've run into those types of things before. I want to show you something today that you may have seen before, but just don't necessarily know how it works, or maybe even where it came from. But that's called the box plot. It's also known as the box and whisker plot. And the reason why it's called that is because you have a box in the middle, and that box is split into two parts, okay? And then you have something like this on one side, and then something like this on the other side.
Science experiment.
Those are the whiskers, all right? You see these often in science experiments or science class or whatever. They're used a lot in those cases. But what we have here, this box plot, obviously seeing the box and the two whiskers on either side, it's kind of obvious, but you'll notice there are 5 key values that are used to make this box plot. We have this value down here and this value up here, and then we also have values here, here, and here. Okay? Those 5 values are the values in what we call the 5-number summary. Okay? We have the 5-number summary. So we're going to take a little time here to talk about those values and where they come from. All right? And the first thing, this is not one of the 5 numbers, but the range uses 2 of those 5 numbers, and these are the easy ones, the max and the min. Okay? The max and the min. Now, max just stands for maximum. Min stands for minimum. Okay? So you put your min value over here on the left. You put your max value over here on the right. Okay? And usually, those will be the ends of your whiskers. Okay? It is possible for them not to be, but we'll look at those special cases later. Okay? So now we want to talk about quartiles. All right? And anytime you see that root word quart, you're thinking quarter or fourths, right? And basically what we're doing here is we're going to divide our data into quarters. Okay? And if you look at our box plot, it's kind of divided into quarters as well. All right? If you think about it here, here's 1/4, and that is way too big. Let's try this. Okay? Here's 1/4. Here's another quarter. Here's another quarter.
The medium 50%.
Okay. And then here's the last quarter. Now, the thing with this is, what we got to understand about these quarters, you'll notice they're not all the same size as far as their individual ranges. Okay? For example, this second quarter right here, okay, this quarter here is kind of tightly grouped, whereas this quarter here is spread out a little bit more.
May I have your attention?
All right, so they are not all going to be the same size. However, what is going to be the same is the number of our data points in each of these ranges. Okay? We just divided our data into 4 equal parts based on how many data points are in there. Okay? So if we had, say, 80 people in this data, that this data represented, 20 people would be in this range of values, 20 people would be here, 20 would be here, and 20 would be here. Their individual scores may be really close to each other or really far apart from each other, but we just divided the group of scores into quarters by doing that. Okay? Now, let's talk about the values that actually divide these things. Okay? The first quartile we refer to as Q1. Okay? You'll notice it says it's greater than 25% of the data. Okay? How many of you ever have heard of the concept of the percentile? Okay? A percentile, if you're, say, in the 90th percentile, that means that you scored or you performed better or higher than 90% of everybody else who did that particular thing. Okay, you're in the 90th percentile. The first quartile is basically the 25th percentile. Okay?
So the lowest one.
Yeah. So if you scored there, then you are greater than 25% of the data. Okay? So this right here is Q1.
The box or the line?
The line. Okay, and that's very important. These are specific values. Okay? They're specific values, not ranges of values. Okay? So that's the value that would put you better than or higher than the bottom 25%. Okay? Now notice here, it's the median of the data that lies below the median of the whole set of data. Okay? And that kind of leads us to our second value here. Okay? And that is the median. The median here, which we could say is what percentile?
50.
Yeah, that's the 50th percentile.
Q2?
You could call it Q2.
People don't call it.
All right?
Just call it half.
You could refer to it as Q2 if you really wanted to.
Or if you're
Okay.
forming a cover YouTube band.
And then finally, we have this other end of the box right here. That is our 75th percentile. And that's known as our third quartile. Think it's 3/4. Okay? It's the value that's greater than 3/4 of our data. Okay? Yes?
The Q3 is about greater than 50%. So if 1 to 100, so the number in Q3 should be big, larger than the 75.
How?
Wait, I'm not sure I understand. Say that again?
Yeah, I think you say Q3
Mm-hmm.
is greater than 55%. So for example, 1 to 100. So the number in Q3 should be like bigger than the 55. Yeah.
The numbers themselves can be anything. Okay?
Yes.
Like, I could have a value that's equal to 3 somewhere in that range. Okay? It's not the numbers themselves, it's where they are in relation to all the other scores. Okay? And I think we'll see that maybe once we do an example of it, of actually making one of these.
Yeah.
I think that'll make sense. That's a percent, though. Okay?
How to get Q1 and Q3?
How do we get Q1 and Q3?
The median of the minimum with the median with the optimum number.
The Q1 is the median of everything below the median of the whole set.
And the Q3 is the median greater than the.
Yes, okay, the median of the everything above the median of the whole set, okay? Now, before we actually do an example here, look down here, there's a term that you need to know, this is part of our vocabulary, and that is the interquartile range. All right, so those of you who are English scholars, all right, this prefix means what? Within, okay? Within or between, that kind of an idea. The rest of the word is quartile, right? So, and we're finding a range, right?
5 to 75%.
So, yeah, we're finding the range of values between the quartiles, okay? Q1 and Q3. So just like we did max minus the min, we're doing Q3 minus Q1 to find the IQR. Okay? So right here, this range here is our IQR. Okay? Interquartile range. The range between the quartiles. Okay, so let's take a look at one where we're given the 5 values and see how this is made. Okay, so notice here we have our 5-number summary. They summarize that for us again here. The 5-number summary is these right here for a particular set of data. So if I were drawing this, we already have it here, but just to show you how I would do it, first of all, you need to come up with a scale on a number line below your graph. Do not draw your number line going right through your graph. Okay?
We have to have the number line?
You should, yes, you should have a number line with a scale there. Okay? And what you'll do is you'll plot these points. Okay? So the minimum is at 1. So here's 1. So you're going to put a point there. The max is at 15. So up here is 15. You put a point there. Okay? You may want to do this before you even fill in the rest of your scale for your number line, just so that you get a scale that makes sense. Alright, then we have Q1 is 4, so I'm going to come here to 4 and I'm going to draw a vertical line. My median is 6, so I'm going to come to 6 and draw a vertical line there. And then my Q3, my third quartile, is 9.5, so I'm going to come here to 9.5. And draw a vertical line there. Notice now that I have those 5 values marked, drawing my box plot's really easy, okay? I simply connect the tops of these vertical lines and the bottoms of the vertical lines to create my box. And then I connect each side of the box to that extreme value to create my 2 whiskers.
So all the numbers in the box are all the numbers in the interquartile range, like varying from the median?
They lie within the interquartile range, yeah. The interquartile range is just a number, though. Remember that. Now, what this says down here, though, that you could kind of see, it's the middle half of the data set. Or you could say it's the middle 50%. Okay? Often we will look at the middle 50% to see how kind of the average scores are, because that upper 50% or that lower 50% might be skewed a little bit because of like one really, really high score. For example, in this data, I might have had this top 25% might have looked like this if I put all the points there. I might have had 4 there and just 1 way out here. But yet it looks as though our top 25 was really spread out a lot. Okay? So that's why sometimes we'll just look at that middle 50 and draw some conclusions from that. Okay? All right, so let's practice with one. Okay, here's some data. Here are some test scores of 9 different students. Let's set up our 5-number summary, find the IQR, and make a box plot for this. Okay, so what's any one of those numbers that you happen to see?
87.
87 is what?
Median.
Okay, 87 is our median, so I'm going to circle that, put it down here.
84 is Q1.
No.
83.
What do you think?
Yes, it's 84.
And then the other one would be.
Well, hang on, let's stick one at a time here. Would our Q1 be 84, or I heard an 83.5?
It's between,
No, if you have your whole value, it'd be
you set up
84.
78 to 87 and then you cross it out, so
No,
it would be
it'd be
84.
Yeah, wait,
I think it should be 84.
Or would it be both of them?
We
We still have.
Can't be both,
Yeah,
yeah.
it's 84, because you cross out 78, then 87, then 83, then 85, and then you get 84 as the median.
All right, hang on. Look back at your definition of what Q1
It'll
is.
be
The
84.
median of the data that lies,
Wait, read it.
83.5.
Hang on, read the whole thing nice and loud.
The median of the data that lies below the median of the whole set, so it doesn't include the median.
Okay, good. It's the median of the data that lies below the median of the whole set.
So it's 83.5.
So it is 83.5. Okay? All right?
Yeah, I need red. Why is he even here? No, why is he even
All right.
To inject life into the classroom.
All right. So now, what's another value we can find?
Minimum.
Good. Okay, we're getting the easy ones now. All right, so the minimum, we got 78, right?
Yep.
All right, what else?
95.5.
Good, the max is 98. And,
95.5.
okay, good. The 95.5, if we're getting Q3, it's going to be halfway between the 94 and the 97. So that is 95.5.
Accurate.
Okay?
It's 12.
All right, good. So the IQR, how are you finding this?
Q3 minus Q1.
Good. 95.5 minus 83.5. And that's 12. And notice we figured all that out. We don't even have the graph yet. Okay? But now let's go ahead and draw the graph. Here's how I would do it if I were doing this, okay? I don't have a scale on my number line yet, so I'm going to put marks for 78 and 98 because those are the min and max points, okay? So here's my min and here's my max. All right? Then notice that's a range of how much? Yeah, the range here is 20. Okay? So that means that 88 would be kind of in the middle. I could make this like 83 if I wanted, and make this at 93. It really doesn't matter how you divide it up. You could count by 2s if you want. You could count by 4s if you want. But you do want to make it proportional. Otherwise, you won't be able to really tell anything you're supposed to tell just by looking at the graph. Okay? So let's think about our different values. My median is 87, so that's going to be about right here. Okay? So there's my median. Okay? Q3 is 95.5. That's going to be a little bit above 93. Okay? So maybe somewhere around there. That's Q3. Okay? Q1 is 83.5, so it's going to be right about here. Okay? And you guys don't have to color code it. I'm just doing that for kicks. Alright, so now we have our graph. Okay? We can finish drawing our box by connecting the tops and the bottoms of those vertical lines. we can draw the whiskers going from each side of the box out to the min and to the max. Yes, Sam?
What did the whiskers show? Like,
The whiskers show us the bottom 25%
oh,
and the top 25%. So I can tell from this that the worst 25% of the students in the class still scored between a 78 and an 83.5. So that's not bad. You know, the worst performance in the class was still a C plus to B minus. You know, the top performers in the class were between a 95.5 and a 98. That was my top 25%. And the middle 50% was between 83.5 and 95.5. Okay? Yeah.
Where would you plot your points? Are you gonna plot points for the data set?
We won't actually plot the actual data, we're just summarizing the data with this graph.
Okay.
Now, I can tell a couple of things here. There's not a lot of difference, but notice how my top 25%, this whisker, is shorter than the distance from the median to Q3. It's much shorter. So that means that the people who scored from the 50th percentile to the 75th percentile were a little more spread out than the people who scored in the top 25%. They were kind of bunched up there at the top. Okay? Those are some things that you could tell just by looking at the graph here. Okay? Any other questions about this though? Okay. Let's kind of take this box plot here and answer some questions about it. All right? This summarizes the class results for a test out of 100 marks or 100 points. Okay? So these are the results for our students. All right? So let's see what we come up with here. It says the highest mark scored for the test was what?
98.
Yeah, 98 right here. That's our max at 98. Okay? The lowest mark was?
25.
A 25. Somebody should have come to extra help. Okay? Half of the class scored a mark greater than or equal to what? 70. That's the median, right? Okay? That's the median. When you see the 50% or the halfway mark here, that's our median. Okay? Now the top 25% scored at least how well?
85.
Okay, good, 85. That third quartile, that's the 75th percentile, which means 25% of people did better than that. So good, that's 85. And then, how did the middle half of the class do?
55 and 85.
Okay, good. 55 to 85. Okay? 55 to 85. So the half of the class scored between, a high F and a solid B. Okay? Right. Now, what's the range?
73.
73. Okay. 98 minus 25. 73 points. That's a large range for a test, right? We'd like that to be a little smaller, I think. And then what's the IQR? That's right, 85 minus 55, so 30. Okay?
Are there any shortcuts?
No.
Like to find the median, to find Q1 and Q3, there's no shortcuts.
No, not really. You just gotta find medians. Okay? Does that make sense? Not too bad? Alright. One thing I will say, now I want to address a couple of things here related to how our data is distributed. We've looked at histograms and these kinds of charts, but also with the box plots. I like these pairings of the graphs because it allows us to see kind of a side-by-side comparison. Okay, and we're talking about, is the mean skewed? One of the biggest misunderstandings is what exactly we're talking about being skewed. If you don't understand this, you will probably get this backwards. Okay? So, a symmetric distribution is one where the mean is pretty close to the median. Alright? So as you look at this data, also we can see there's kind of a bell shape to our data here. This would be a symmetric distribution. The mean is going to be somewhere around here. The median is, of course, right there at 15. So the mean and the median are pretty close together. That's because our data is distributed pretty symmetrically on either side. Okay? Now, there are two ways that it could be skewed. Alright? And again, we're talking about the mean getting skewed. Alright? So let's start with positively skewed. Okay? This data here you can see is positively skewed because the majority of our data is down here, right? The majority of our data is down, in this case, here's 75% of our data between 1 and 4.5. Okay? However, we've got a few of these really high scores. And when we find the mean of all of this data, what's that going to do? What are those high scores going to do?
Bring it down. Well,
What are they going to do, the mean?
they're gonna skew it to the higher side.
Yeah, it's going to pull it up. It's going to skew it to the higher side, to the positive direction. Okay? The mean is going to get pulled in the positive direction because of these few high scores. Okay? So when we're talking about positively skewed, we're talking about data where the mean is significantly more than the middle as far as the median is. Notice the median here is at 3. Okay? If you were to find the mean of all of these, because we've got a couple of 6s, a couple of 7s, and an 8, that's going to pull the mean significantly higher than 3. Okay? So the mean is significantly greater than the median. That's what we mean by positively skewed. Okay? Now, to be symmetrical, it doesn't have to be to where they're exactly the same, but they should be pretty close relative to all of your data. Here, it's not that our mean just happens to be a little bit more than what the median is, but it's significantly more than what the median is. Okay? But that's positively skewed. Most of the data is down in the lower end, but a few high scores pull the mean up. All right? On the other hand, we have negatively skewed. Notice in this case, the majority of our data is high. These high values, Okay? There's the majority of our data in these high values, but we have a few low scores that are going to pull the mean down this way. Okay? The mean is significantly less than the median. Okay? Notice here the median is at 7. On our box plot, we can see that real easily. But if we were to find all the mean of this, it would be significantly less than 7 because of those really low scores. Okay? So in general, think about this, okay? If you're talking about whether or not data is skewed, look at where the majority of the data is, okay? And are there some extremes on one end or the other that are going to pull our mean in one direction or the other, okay? On the box plot, it tends to be a little easier to recognize because you'll see like on one side, the whisker is a little shorter, but on the other side you've got this really long whisker, okay? See the same thing over there, okay? That means that's indicative of the idea that, we've got these scores way down here that are going to pull the mean because this whisker is so long, it's going to pull the mean down to the left of where the median was. Okay? So, relatively simple concept. It's easy to mix them up though. So just make sure we're talking about the mean getting skewed one way or the other. Okay? The last thing I want to talk about here is the outliers. Okay? We've already mentioned the IQR, and I told you that there was a reason we were looking at that. We were going to use it, and here's where we're using it, okay? We use outlier in a generic sense a lot of times, but there actually is mathematically kind of an accepted way to identify an outlier, at least when we're dealing with box plots, okay? And that is, we kind of create a window for ourselves using the IQR. And the IQR kind of tells us what the reasonable solutions would be, okay, or reasonable data. So to create these boundaries, what we do is we take the IQR and multiply it by 1.5, okay? So, as an example here, right here our Q1 is at 6.5, our Q3 is at 10, okay? So, we have 6.5 and we have 10, which means the IQR is 1.5 times the 10 minus 6.5, okay? Or I'm sorry, not 1.5 times. 1.5 times the IQR is 1.5 times the 10 minus 6.5. Okay?
Wasn't it just Q3 minus Q1?
That's the IQR, okay, and that's what we're finding right here. IQR is this, Q3 minus Q1. But to create these boundaries here, the upper and lower boundary, we're going to use 1.5 times the IQR. Okay?
So 1.5 times IQR is equal to?
In this case, 1.5 times 3.5. Okay? So that's going to take us up to 5.25.
So you always use 1.5?
You always will use 1.5.
So anything after 1.5 is an outlier?
Well, anything beyond 1.5 times the IQR. So let's actually take a look at this, because one of the things you got to make sure you do is that you're counting that 1.5 IQR, in this case the 5.25, from the right starting point. Okay? So notice here it says the upper boundary. The upper boundary is the upper quartile. Well, that is your Q3, right? your Q3 plus 1.5 times the IQR. All right? So your upper boundary is Q3, which is 10, plus that 5.25 that we just found. Okay? So 15.25 is the furthest a data point can be, or it's the highest it can be without being an outlier. All right? Now, one thing some students like to do, you don't have to do this, but sometimes students will like to kind of put a dotted line where that upper boundary is. All right? So 15.25 would be right here. Okay? So you'll see that's why this data point right here, we put a little asterisk. You can use a little X, you can use a little star, all right? Something like that to indicate that that is an outlier. Okay? An outlier is simply a data point that's beyond a reasonable distance away from all the other data. Okay? Now, you'll notice in this case, the whisker doesn't go all the way to the boundary. Okay? And that's where this little guy here is telling us each whisker is drawn to the last value that is not an outlier. Okay? So in our data, we must have had a score of 16. The next highest score must have been 14. Okay? So since 16 is an outlier, we only draw the whisker up to the next highest value. In this case, 14. If the next highest value happened to be an outlier too, we'd make that a little X and we'd draw the whisker to the next highest value. Okay? Katie?
So when we multiplied 1.5 times the IQR and then added the upper quartile, that is not to find the outlier. That's to find the last value before the outlier, right?
Yeah, that's kind of like, we're kind of like creating a fence here, and anything outside the fence is an outlier. You know, but that's the furthest you can be and not be an outlier is 15.25.
And are they going to give us the outliers, or we have to find what the outliers are?
You're just going to be given data and asked to give a box plot for it. You're going to need to check what's my IQR, where are the boundaries for my outliers,
Okay.
and identify them if necessary.
So it wouldn't say identify this, your upper boundary, your lower boundary, and your two outliers, because if you find the upper and lower boundary, it doesn't necessarily mean that you know where the outlier is, right?
Not necessarily, and you may not have any outliers. Okay? You may not have any outliers. It's not necessarily the norm to have outliers. Okay? Yes?
So, if each whisker is drawn to the last value that's not an outlier, why does it stop at 14 if we said 15.25 is not an outlier?
Well, it's the last actual value or data point. Okay?
15.25, no one actually scored that.
No one actually got a 15.25. That's just the highest they could have scored and it not be an outlier. Okay?
So what does the asterisk on the 16 mean?
That's the outlier.
That's the outlier. So somebody got a 16. And you can do a little X like that. You can do an asterisk, whatever you want. Okay?
So what's 15.5?
15.25.
No, like 15.5, is that an
Oh,
outlier?
yeah. If it were 15.5, if it were 15.26, it would be an outlier.
You just have to put it on the first whole number?
No, you put it on,
The first
the
value?
highest score that somebody actually got was
Okay.
14.
Yeah,
So that's where your Q3 or whatever it's gonna be, not your Q3, your.
your the end of your whisker. Yeah.
And then the 15.25 is the highest you could have gotten without being an outlier. Because 16 is when you hit outlier.
Okay,
Okay.
okay.
On the lower end, it takes some getting used to. On the lower end, it's kind of the same idea, but we're going from Q1. Okay, Q1 was 6.5. So now we're going to subtract 5.25, and we get 1.25. All right. So what that means is the lowest score we can actually get without being an outlier would be 1.25. However, if you notice here, there's the boundary there at 1.25. Okay? So anything to the left of that is an outlier, and you'll see we actually do have an outlier here at 1. Okay? So even if it's really, really, really close, if it's past, you call it an outlier. Okay? So that right there is an outlier. Now, in this case, the next highest score must have been a 3. Okay? So one of the data points was a 1, it's an outlier. So we look at our data, the next highest score is a 3. So we draw the whisker to 3. Okay? And that's how we do a box plot and identifying our outliers, okay? Again, the bottom boundary is Q1 minus that 1.5 IQR. All right? Okay. All right. I'll put this in here. You can take a look at these and try to match up the box plots with what they've got a little later, but you can see here examples. I'm going to zoom in these and use this for this instead here. Notice here, in this example here, your IQR is 2. It goes from 5 to 7, right? So 1.5 times that is 3, okay? So, think with me here. I go 7 up 3. Ooh, look at that. This one point right here was right on the boundary. Okay? But this one out here was actually past it, so that's an outlier. Okay? I go to the 5 and I go down 3. Well, here's my boundary there. Okay? So somebody got a 1. So that's an outlier. But the next highest score must have been a 4. So I only drew my whisker to go to that 4. Okay? And if you look at the graph this goes with, this actually goes with C right here. Okay? Notice here 1 is an outlier and 13 is an outlier. 10 is a little bit separated, but it was not an outlier. Okay? So you can kind of see how this bar graph looks compared to the box and whisker plot. Okay? So you could look at the rest of those, try those if you like. Okay? Alright, I gave you some other practice there that you can do. And the independent practice, of course, as well.